Alright, we back online.
Yep.
Okay, we're back in. Expected numbers. I guess before we do this, we better go over our formulas real quick. Does everybody remember the formulas for superheat, subcooling, condenser TD, evaporator TD?
Saturation temperature minus.
Tell me how to,
converted
if I want to
pressure.
find, before we do expected numbers, let's do formulas. Really fast. If y'all are about to go on internship, so if you don't have this burning in your head, like it's time. Like tough love, man. It's time to get this burning in your head. Number one is superheat. Superheat. Let's do superheat. If I want to find superheat on a unit, what are the two readings I got to take?
Saturation.
Okay.
And
Saturation
you
of
gotta
what?
take your temperature.
Oh, we know that.
Superheat happens in the evaporator, right? We need to go to the
So the
refrigerator.
temperature of the evaporator minus the saturation temperature. Because don't you have to convert one with the chart?
Yes. First thing I'm gonna do is I'm gonna clamp on the suction line. And then I'm gonna take and subtract my low pressure converted to temperature. And that will give you superheat.
What is the LP called?
Low pressure. You can spell it out if you'd rather. Yep, low pressure converted to temperature. Here, I'll go ahead and spell it out. Low side converted. Low side converted to temp. Degrees Fahrenheit. We're gonna go over the refrigeration circuits now.
Been too long, been staring at electricity for.
Yeah, I get it. Now you're gonna tie it all together. You guys gotta go on an internship knowing how to troubleshoot electrical stuff and know how to troubleshoot refrigeration circuit. If I wanted to explain superheat to my 15-year-old son, he turns 15 tomorrow, right? It's crazy, right?
He probably already knows.
He probably does, honestly, right? But if you wanted to explain superheat to somebody who's not an air conditioning person, like say I wanted to explain it.
My mom.
Yeah, or Hammondtree, right?
Oh yeah, that's more of a better example.
How would you explain superheat to Hammondtree, y'all? What's the definition of superheat? I'm sorry.
The excess.
Superheat? Alright, I'm gonna give you guys the benefit of the doubt, because I know you're a sharp bunch. And y'all just having an off day.
Yeah, thank you.
No, y'all have been a phenomenal group. I'm kind of shocked right now. Superheat. Give me the definition of superheat.
Liquid heated higher.
Any temperature
added.
Or vapor.
Any
Right.
excess liquid burn.
I've never had
He's
this
asking you,
happen.
man. He forgot. He needs you to remind him. That's
Oh,
where
okay.
the last dude. What
Yeah.
What do you need superheat?
Right, it's on your ticket.
The amount of heat added to a vapor.
My man! Say it again.
Amount of heat added to the vapor.
Let's leave it at that.
The amount of heat added to
Be
a
confident, dude. I heard you say it
point
like 3 times.
Did he?
Yeah. He was like, yeah,
Let's just
gotta
keep
say
it simple. Heat added to a vapor.
Y'all be wrong in here, not out there.
You're right.
You know what I mean?
I'm wrong in here every day.
Right, though. That's your one right there.
Heat added to a vapor. If you look at the full definition in the book, it's any heat added to a vapor above its saturation point, right?
That's what Siri said.
It is. Alright.
Crap, he's gonna ask us about stuff.
Right, Hammondtree's already pulling up. He's like, hey Siri.
Our motor windings were spinning after the last one.
Superheat is heat added to a vapor. Hey, where's the main place that we care about superheat? Where do we usually check in? Where does the superheat happen at? The evaporator. It happens in the evaporator. It happens in the evaporator. We superheat in the evaporator because we change to a vapor in the evaporator, and then we add a little bit of extra heat to it. So it's above its saturation. It went to a vapor. We add heat to it, right? So why do we need some superheat? You guys already said this a while ago because I said, what if we have 0 degrees of superheat? So why do we need some superheat?
So we can make our conversion and not slow compressors and.
Slow, yeah. So we need, that's the main thing. If I'm checking superheat at by my grandma's house, right? And I'm checking her superheat, and if she's got 0 superheat, I know there's liquid getting back to the compressor. So superheat is heat added to a vapor. It ensures no liquid to the compressor. It's insurance, y'all. If I got 5 degrees of superheat and I'm using trusted equipment, like I know this low side pressure is right, I know this suction line temperature is right. If I got trusted equipment and I've got a few degrees of superheat, I know it converted fully over to a vapor. Does that make sense? Oh, we're going to do the refrigeration circuit again. That's superheat. It happens in the evaporator. Where else, there's only one other place that we heat up vapor in the refrigeration circuit. Where else does superheat happen at that we don't really care about? In the evaporator? Where else is there only vapor?
Is it the expansion one or?
Say it, Hammondtree.
Compressor.
At the compressor. It's a vapor pump, right? So if I have vapor coming in, big flex. If I have vapor coming in and vapor leaving, the vapor coming in is nice and cool, right? It's keeping the compressor windings, it's keeping the compressor all nice and cool. We got nice cold suction gas, nice cold suction vapor. But then by the time it leaves the compressor, is it still nice and cool? Nope, it came in as a vapor and left as a vapor, but it came in as a cool vapor and it leaves as a very hot vapor. So we added a bunch of heat to that vapor so it's superheated in the compressor. And then we send it to the condenser. Big flex, bro. Good job.
Show off.
Let's do subcooling. What's the formula for subcooling?
High side minus liquid line.
Yep. High pressure converted. Converted. Minus liquid line temp. And that is subcooling. Now, write that down, and I'm serious, like you gotta burn this in your head before you go on internship. I know it's been a while since you guys have had applications, but you gotta know this. You have to, period, game over. All right, Hammondtree, keep us going. What is eye contact? What's the definition of subcooling?
Cooling added to a liquid.
Okay.
Technically not.
All right, there's no such thing as cooling, all right? We can transfer heat, so why don't we say
Heat rejected.
okay, heat removed, heat rejected from a liquid. Heat removed from a liquid above its saturation. So it means we had to have 100% liquid, then we cool it down a little bit more. If our liquid line is cooler than the high side converted, we have subcooling. And if we have subcooling, It ensures 100% liquid. Why do we need 100% liquid? Where's this liquid headed to?
Our metering device.
Yep. Yep. It ensures 100% liquid in the metering device. Just insurance, right? Subcooling is insurance that we have 100% liquid. Superheat, 100%. It's insurance for 100% vapor.
Y'all knew this, it's just been a while. For y'all to be the caliber of class that y'all have been, and then for this to trip y'all up, I'm gonna let it slide.
This was the first thing we went over, man, like first semester.
I know.
Like,
Should make t-shirts. VCR t-shirts. Ask me
Y'all
about.
got any more of these cards?
I'll make y'all a t-shirt that says, ask me about super.
Yeah, don't sound like guys don't.
You have to wear
It's
it.
weird because like, I remember this, like, writing it down multiple times on a piece of paper to remember it. And like, I literally do not remember it.
what 100%
Metering device. In metering device, yeah.
My gauges.
I feel like everything that I learned in applications just.
It's still there, I promise you. The stuff I learned in electronic controls with Mr. Walker in 2002, 2003, some of that stuff still pops out at me. I'm like, oh yeah, like it's still there.
You just haven't applied it yet, I mean.
That's true. First time I ever messed with like zone temp sensors and stuff like that. I'm like, I don't remember how this thing works. And all that PTC and NTC thermistor stuff started coming back at me and everything. Y'all know that, right? I didn't use it, yeah. So it's still there. You just gotta dig for it. And most of you guys learn hands-on and not visually, so this is different than being like, oh, okay, I got it now. But as soon as you can tie this into this, is when you're going to be successful and get big paychecks. All right, so we did subcooling, we did superheat. What cards were you asking about? The one that says the 6 readings or 4 readings or whatever? I won't catch it. It's all right.
It said rules of thumb for AC systems.
Who gave that to you?
Cole.
Colt who?
Like the president.
Oh, Colt Short. All right, yeah, I'll check it out.
We don't like rules of thumb.
Yeah.
Ethan had them. Where do we get those?
Yeah, that's what I'm saying.
All right, let me see it.
Better shoot it down.
I ain't gonna go that way. It's booby trapped. Yeah, I'll give you some. I'll give you some today. Don't we forget when we get out of the lab, we'll track some there. Hey, where does subcooling happen at? Trevor Long, where does subcooling happen at?
I don't know. Maybe that's it.
Yeah. Clark, where does subcooling happen at? Where does subcooling happen at? Where does superheat?
Can you do
The evaporator.
refrigeration stuff?
And?
Real quick.
and the to the compressor.
Yeah, there's some yeah. We don't care about compressor superheat so much, but if we're talking superheat, we're talking about the evaporator superheat, right? Where do I leave off at? All right, so Hammond Tree are gonna be the next one where I start questions at. No pressure. All right, here's the third thing. Let's do condenser TD. Y'all know about condenser TD?
Heck yeah.
Get excited, man. Y'all about to go make a pocket full of money knowing this stuff right here.
Temperature difference?
It is a condenser temperature difference, right? How do I find condenser TD?
High side, run roll minus outdoor air.
My man.
Dang, get me too.
Head pressure converted. Head pressure converted to temperature minus outdoor air. That will give you condenser TD. Rules of thumb right here.
Where do you get your outdoor air?
Good question.
Outside.
It's a good start.
Not inside.
You get it 50 feet up on the roof, 60 feet away from the condenser.
Above my pay grade so far.
What's the load on that condenser? It's the air that's right there around it. I would take the air that's right there around the condenser.
Get you a little magnetic temperature thermometer and stick it to the side.
Yep.
Or just hold it.
That's usually what I do. You guys have the clamp on thing, like with the electronic gauges and stuff. If you got one of them, before I clamp it on any line, before I clamp it on the suction line, before I clamp it on the liquid line, I just hold it by the condenser for a minute. I'm just like, all right, 92 degrees outside. Let's go. Boom, 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 boom.
You
Take
do
a
it with a
reading.
line temp clamp?
Hmm?
With
I usually
a
do.
line temp clamp?
Yeah.
Oh.
So I use a pipe clamp, like the ones that y'all use with your digital gauges and stuff. I just hold it in the air, get my outdoor temperature, and then start clamping on lines. Anybody got any digital gauges?
Yep.
Both of y'all? Oh, just, you like them? They're cool. I've never owned a pair. I'm old school. Condenser TD. What does condenser TD tell you?
Temperature difference in the condenser.
Yeah, it does.
How much heat's being taken out of it?
Why, huh?
How much heat's being taken out?
Yeah, why do we take condenser TD?
Well, Brian, you're on a roll.
You are.
Brian, why would you take condenser TD, Hammertree? He's like, that wasn't in the picture I've been looking at.
I'm right on my brain right now.
Well, what are we comparing? Outdoor air to our head pressure, right? We can't change outdoor air, right? This is Mother Nature, this is God doing this, right? It tells us, is my head pressure okay? And the easiest, I mean, like it tells you, I don't know how to even put this into words. If head pressure is normal, low, or high. Because if you get out there and you get stumped on one, you're going to try to call somebody. If somebody calls me, they're like, man, I'm running high head pressure. I'm like, I'm not even listening to you, man. Like, what's your condenser TD? Like, what's your condenser TD, right? And like, it's high. I'm like, what is it? What is it? What is it? And we'll talk about normal numbers. That's what I was getting ready to start with, was expected numbers. But did y'all ever talk about what you expect as a condenser TD? It'll be 20 or 30. But I'll beat you guys up on this tomorrow, Monday. Condenser TD just tells you, is my head pressure okay? When compared to the load. This is the load that's on that condenser, right? So if it's 410A, then it's 13 SEER or above. You guys know about SEER ratings, right? SEER is just like how much electricity do we use to produce that many BTUs. So when did we mandate 13 SEER? Was it 10 years ago, 12 years ago? Maybe something like that? Yeah, it was 10, 12 years ago. So if it's 13 SEER, if it's 410A, you have a 20-degree condenser TD. If it's an old girl, an old 10 SEER, you have a 30-degree condenser TD that runs higher head pressure, right? If I have a higher condenser TD, outdoor air is here, my head pressure is either going to be 20 degrees above that or 30 degrees above that. So just about everything you guys are going to touch, majority of the stuff you guys are going to work on will have a 20-degree condenser TD. My high side converted will be 20 above my outdoor air. It's 90 outside. As soon as I screw the high side gauge on, I'm looking at the pink numbers for 410A, right? If it's 90 outside, what am I looking for on my high side? 110. So I don't do condenser TD this way. I do it backwards like what I just showed you guys. I already have the outdoor air. It's 90. As soon as I screw my high side gauge on, I'm looking for 110. If I'm working on that machine, right? And then this one gets a little more tricky, but let's talk about evaporator TD. And we're gonna straighten up some terminology. Evaporator TD versus evaporator split. So evaporator split is just return air, supply air difference, which in my opinion is a worthless reading to take, in my opinion. Come back and tell me I'm wrong. Find a unit that's lost like 30% of its charge and it'll still have a 15 to 20 degree split, but it won't be doing a damn thing to the latent load. It won't be doing anything to the humidity. But on the sensible side, you'll still have a 15, 20 degree split. So evaporator split, I think, is a worthless number. I've totally taken it before if I suspected a return air leak or something. If I was reading high superheat, high suction pressure, I'm like, man, there's a big load on this evaporator. Then I'll go to the furnace and do return air and supply air. If the house is 75, but my return air is 85, I know I'm picking up a bunch of heat somewhere in the return duct, right? As it's traveling through the attic and things like that. But typically, evaporator split is not a reading I hardly ever take. Evaporator TD is where it's at. Alright, so evaporator TD. What's the load on this evaporator?
The air going across it.
Yep. The air going across it, the return air, right? The air that we're getting ready to shoot across the evaporator, the air that we're getting ready to pull through the evaporator, whatever. So we're going to go return air minus low side converted. That will give you evaporator TD. What are we taking that temperature with on the return air? Just a regular old thermometer? Yep. So here's the downfall to this. This, like condenser TD, you can almost take it to the bank. Like it's pretty black and white. But when we start checking the load on the evaporator, if we're only checking the sensible load, just the sensible temperature, right? We're not even looking at the humidity, and that latent load is a huge load on it. If you have a really humid house, if you're doing a humid pull down, your suction pressure is going to go up, suction pressure is going to rise, right? So if my return air is here, my low side's here, and I add a bunch of humidity, it's going to raise my suction pressure and make them closer together. So I'll have a low evaporator TD because I have high suction pressure. Everybody catch that? They get closer, right? So return air stays the same, but we add a bunch of humidity in it. It's going to raise the suction pressure up. So now I have a less of a difference between these two. So I have a low evaporator TD because I have a high suction pressure. Yeah, so this one's not as black and white. This one's not as cut point blank as condenser TD. The condenser gives zero damage about the latent load, basically, essentially. Evaporator's like, that's my job. I'm going to bring this humidity out. I'm going to bring this moisture out the air, right? It's a load on that evaporator. All right. Evaporator TD. Normal evaporator TD, 30. What's evaporator TD tell you? If condenser TD tells me if my head pressure is okay, what do you think evaporator tells you? Evaporator TD. Tells if my suction pressure, that was all about the head pressure, right? Head pressure's happening in the condenser. Now we're inside in the evaporator. Tells if my suction pressure is normal, low, or high. I'm using specific terminology here, right? Sound like Mr. Lamb, Dr. Lamb. I'm using specific terminology here because we're going to start dissecting refrigerant issues, refrigeration circuit issues. You ever notice Mr. Lamb's like, he uses the perfect words for everything, right? He don't have much of Milwaukee County in him.
He's a smart cat.
You just said that on video.
I did.
Video evidence. Yeah, edit that out, man.
Yeah, get his head so big, won't even fit through the damn door, huh?
Barely gets in now.
I know. He's got to like turn like this to get his head through the door. You ever seen him get in his car? Got to go head first. Right? No, Mr. Land's a smart cat. Mostly self-taught too. Like that dude, he's intelligent. Anyway, it tells you is my suction pressure, evaporator TD, is my suction pressure normal, low, or high? Alright? Let's add something to subcooling real quick. Remember we said subcooling, so go back in your notes just a little bit. Subcooling, we said, ensures 100% liquid to the metering device. Alright? But subcooling is also like a fuel gauge. And you want to, subcooling tells you, I'm going to answer it with a question. Is my condenser normal, starved, or flooded? Subcooling is just telling you, is my condenser normal? Is it starved, meaning there's no liquid? Or is it flooded, meaning we got lots of liquid? Because what's the definition of subcooling?
Heat removal.
Heat removed from a liquid, right? So if I have a lot of subcooling, I remove the heat from a lot of liquid. So high subcooling, high liquid. Low subcooling, low liquid.
Question.
What's up,
Other
man?
than normal, out of the starved or flooded, which one would you typically see more?
Oof. Depends on what the issue is. That's what we're gonna spend the next 2 weeks going over is nothing but this stuff right here. I'm gonna just keep beating you guys up with different issues. Like we're gonna go over the refrigeration. We're gonna recap on this Monday, and then we're gonna go over the refrigeration circuit Monday. And then by Tuesday, I'm gonna be hitting you guys with like what's wrong with this unit. I'm gonna draw the refrigeration circuit up here. I'm gonna give you the head pressure, the suction line temperature, anything you want to know, I'll give it to you. And you're gonna have to figure out what's wrong with that unit. So it just depends, man. Hey, if I'm overcharged, am I gonna be normal, starved, or flooded condenser? Flooded. So what's my subcooling gonna be like?
High.
Lots of subcooling, right, on an overcharge? If I have a dirty condenser, dirty condenser, right? If I have a dirty condenser, my favorite, that's easy money, right? Love cleaning a condenser. Grab the hose, go after that dirty condenser, right? If I have, yeah, that's what I was getting up to. If I have a dirty condenser, what's my subcooling gonna be? Very low. Low subcooling, starved. Subcooling. Superheat. Hey, so remember how I said this is a fuel gauge, right? High number means flooded, low number means starved. Superheat is reverse acting. If I have a lot of superheat, I'm starved. If I have low superheat, I'm flooded. Because superheat is heat added to a vapor. So if I have a lot of superheat, I have a lot of vapor, which means I'm starved. So superheat just tells me the condition of my evaporator. Is my evaporator normal, starved, or flooded? If you start dissecting refrigerant issues like this, man, I think you guys are gonna love it. Because once you take your readings and you're like, okay, my head pressure's high, my suction pressure's high. I know that because of condenser TD and evaporator TD. I got high suction, high head, and I'm flooded on my condenser and I'm flooded on my evaporator. So if you got high suction, high head, and you're flooded, what's wrong with it? Anybody take a guess?
Wait, can you repeat that?
Yep. High suction, high head, So both my pressures are high. I know that because of evaporator TD and condenser TD. Both pressures are high. Flooded condenser, flooded evaporator.
Restriction.
Even with a high superheat.
No, we got low superheat. We're flooded,
Oh.
flooded.
I thought you said they were both.
They're both flooded. All right, let me do this the other way. Yep. Let me do this the other way. I got low suction, low head, starved condenser, starved evaporator.
See, how do you have a start?
I'm just telling you.
Restriction or starved. It's like not enough refrigerant.
Yeah, so it's undercharged, right? So the first one I gave you guys, I said every pressures were high, both coils are flooded. That's an overcharge, right? Next one I gave you was both pressures are low, both coils are starved. That's an undercharge. If you start dissecting like that, it'll help you out so much, man. And or if you have like a flooded condenser and a starved evaporator, or if you have a whatever, you start picking it apart like that. We were just talking about you, Mr. Lamb, Dr.
Yeah,
Lamb.
we asked these guys where they was at, when they're supposed to be in class today.
I fell asleep.
We're still here.
I had three of these guys out of the.
That's
10.
what I heard. That's what I heard, man. Where was y'all at?
Hammer Tree, he's taking care of his babies, I know he is.
Yeah.
I took Will to the hospital.
I woke
Did you guys
up.
all go to Buffalo Wild Wings last night? You didn't?
Mondays and Wednesdays, all you
Mondays
can
and
eat
Wednesdays?
boneless wings and fries for
Boneless?
$19.99. Yeah, they only put the all you can eat on boneless
They're
chicken.
not wings.
But the all you can eat
Chicken
for
nuggets.
$19.99.
Chicken nuggets.
Oh, you can eat
For
chicken nuggets.
$20?
Yeah.
For $20, I can make you throw up on McNuggets from McDonald's.
Oh, what McNuggets from McDonald's? What McNuggets
It's the
from
same thing, chicken
McBuffalo
nuggets.
Wild Wings? They're saucy chicken
We got
nuggets.
2, 4, 6. Oh, you only got 7. You're missing 3.
Missing 3. Willingham,
I know where he's at.
Ellis, yeah.
Okay.
And who was the other one we're missing?
Caden Anderson.
Oh, yeah.
I'm breaking my paddle on Monday. I know these guys are grown men, I don't care.
You know what, Mr. Lamb? I've been so impressed with this group. I was like, man, this is an above average group for sure, right? Like, for sure, this is an above average group. I've been so. And then today, we start air conditioning, right? We've been talking about heat, man. They got sequence operation down. I bugged the units like 40,000 different ways. They're just tearing it up, right? And then today, I was like, what is superheat? And you know what I heard? Not shit, man. Nothing.
He added to a vapor, Mr. Lamar.
Heat added to a vapor, right? I kept it short with them too. Just heat added to a vapor. It's above its saturation
That's
point.
what heat gain after evaporation.
There you go.
Thank you.
Right?
That's Mr. Lamb right there.
Hey, what is subcooling?
Heat removed from a liquid.
Removed from a liquid.
No, it's cooling added to it.
That was the first answer I got. I'm like, okay, okay.
We were like, you're technically not wrong, but that's not how we say it.
That's not how we say that. What country are you from?
We can't cool anything. All we can do is move heat around, man.
Oh, that's good. Yeah, it's all that heat.
It's all about
Heat
heat.
added or removed.
What is superheat? I'm embarrassed. I'm embarrassed, Bryce.
You had him
I
in
just want you to
application.
know.
You know what he said? He's like, I used to know it, but then I had to learn a bunch of electrical stuff, I had to learn a bunch of heating stuff.
I guarantee you, he used to know that.
Yeah, and it came back to him. Came back to him. They'll be good in another day or two. They'll be like, oh yeah, Dr. Lamb did say that.
Dr. Lane.
And then condenser TD, evaporator TD, all that good stuff.
Answer TV. It's Mr. Lamb's favorite one.
I love it, yeah. And what else did we talk about today?
What is
Metering
condenser
devices?
TV, Bryce?
Metering devices, expansion valves.
What else you talking about today?
Metering devices,
Expansion valves.
yeah.
Expansion valves, meter devices, all that good stuff.
What are the 2 categories of metering devices?
Fixed board.
Okay. Fixed board charged by,
Superheat.
yeah. And then TXV, expansion valve, charged by
Subcooling.
subcooling, okay. TXVs maintain what?
10 to 12, or like 10 to 12.
Superheat, yeah, 10 to 12, but then told you guys the train story, how they're like, this thing was good at 30, right? And they put undersized valves and all their stuff because they were blowing water off. So it's not always 10 to 12. That's not black and white, I promise you that. It could be anywhere from 6 to 30, I guess, right? But usually it's 8 to 12-ish, plus or minus a little bit. 10 to 15-ish, something like that.
You get into commercial refrigeration and nothing even makes sense anymore.
Right?
3 degrees.
Yeah.
Average degree.
What's the perfect superheat?
4.
No.
0 to 30.
Okay, that was a fixed bore. I said, what's a normal superheat for a fixed bore? What's a perfect superheat?
12, 15.
What's the most efficient unit in the world? What kind of superheat would you want on it?
10 to 24.
As little as possible. As
Zero.
little as possible. 0.1.
0 with 0 liquid getting to the compressor.
That's it, yeah. You want as little superheat as possible. TXV is a manual valve, right? So we're gonna be like, hey, just maintain 10, 15. We trust you with that, right? But then on an EXV, it's electronic. We're like, hey, give us like 4 to 6. You know, we trust you with that. You can do that. If we could have the perfect world, we'd have just a tiny bit of superheat. Flood the evaporator.
Why is very low superheat the best?
We wouldn't have any heat in our vapor, or heat to take out, I guess, you'd be at good temperatures.
I don't know how to explain it.
Well, yeah,
I'm not smart
I'm thinking
enough.
of the right answer too.
Because 99.9% of the heat moved in a vapor compression refrigeration cycle is latent heat.
Yeah.
You can't move latent heat unless you're boiling refrigerant. So you
Yeah.
always want liquid available. That's
All your humidity removal happens on the flooded part of the evaporator. Not all of it, but a big chunk of it happens on the flooded part of the evaporator, where there's liquid in the evaporator, where we're doing some work.
and that's why a little superheat would be good, because that means more liquid.
Yeah, lots of flooding happening, lots of heat removal happening, especially, yeah. And all your latent, not all, God, I keep saying that, but a big chunk of your heat removal is happening, especially latent heat removal, humidity removal is happening on the flooded part of the evaporator. Do you happen to know where there's like 10,000 extension cords at or anything? Or I'd settle for 1. What happened to all of our extension cords?
We had a yellow one in applications, that's now behind the projector in 112.
They're on the roof.
Because Mr. King needed it. And other than that, I have, some power strips that I use in that classroom. I just ordered those
I don't
a couple
know.
years ago.
We need to buy some.
Do we need to just order rolls of wire and make a bunch of extension cords?
Possibly. I don't think Stan the safety man would be happy with my extension cord.
I wish you can kick rocks here, right?
Who that?
On campus and off campus, OSHA is the law, man.
Yeah.
On campus, we have to break rules to teach.